Hello everyone, and welcome to today's presentation, Mastering Public Cloud at Scale, Monitoring Cloud Native Services with Wavefront's AWS Monitoring Suite, brought to you by Wavefront by VMware. Now, before we get started, I'd just like to take care of a couple of housekeeping items. So first off, I want to make sure that everybody can hear me okay. So if you would, just send me a quick message in the chat window to let me know that you can hear me. Great. If you have any questions for our presenters today, please be sure and post those into the questions panel so we can get to them after the presentation. If you experience any technical difficulties today, like the audio dropping out or screen sharing not displaying properly, please post a message in the chat panel to me, the host, and I'll work with you to resolve those issues. Lastly, we are recording today's presentation and will be making it available shortly after the event concludes. So now that we're through the housekeeping items, I'd like to go ahead and introduce you to today's presenters. First, we have Stella Udovicic. She is a product marketing lead for Wavefront by VMware. While at Wavefront as Senior Director of Product Marketing, Stella led product solutions and partner marketing. So now I'd like to go ahead and do a quick sound check for Stella. So Stella, if you'd like to say hello to our audience, and audience, please let me know if you can hear Stella by posting in the chat window.
Hello everyone and welcome.
Great. Next, we have Connor Beverland. Connor was an early employee of Wavefront and worked with many of the initial customers as they adopted the product. Previously, he worked at IBM in engineering and technical sales roles in Europe and the USA. Now I'd like to do a quick sound check for Connor. So Connor, if you'd like to say hello, and audience, let me know if you can hear Connor by posting in the chat window.
Hey everyone.
Excellent. Well, without further ado, I'll go ahead and turn things over to Stella and Connor to begin the presentation.
Thank you very much, Chris, for this introduction. And here is our agenda for today. First, we will introduce the Wavefront platform and Wavefront Amazon Web Services Monitoring Suite. Then my colleague Connor will run 2 live demos, and we will walk you through real-world case studies and describe how 2 of our customers, SpaceX Games and Box, use our platform to help them confidently scale their services. Today, we see a wide range of customers on their cloud application growth and public cloud journey. Based on their feedback, we have categorized some of the typical obstacles DevOps teams face on that journey. First, because DevOps teams, including developers, utilize dynamic and elastic cloud services, as they grow their cloud applications, they can be left with unnecessary and hidden cloud costs. Engineering teams move quickly, often forgetting unused cloud resources that they are getting charged for. For example, for your Amazon EC2s and EBS, utilization may spike up depending on the time of day or season, only to not be needed after peak times. Secondly, AWS offers an increasing array of cloud services. With all these services and accelerated pace of DevOps, you have to ensure that both your cloud application as well as underlying cloud infrastructures are always available and they're always meeting critical SLAs. And finally, for a typical SaaS environment, operational decisions directly translate into business decisions. All teams must be synchronized with cloud application code releases and updates. If you do not have universal visibility, delays can be introduced. They can be operational, such as delays because you're rolling back code updates, or business impacting delays, such as your customers experiencing sluggishness when checking out an item from, say, your e-commerce website. These lags result in impaired customer experience, reduced developers' productivity, and slowed velocity of your cloud application growth, which can be detrimental for a SaaS business. The Wavefront by VMware platform can help you overcome these obstacles. Wavefront is a metrics-driven monitoring analytics platform that thousands of DevOps engineers, including developers at enterprises such as Box, Lyft, or Intuit, use to monitor the cloud applications that are typically growing at a very, very high scale. We collect metrics from your distributed applications, from your containers, your microservices, from your cloud infrastructures, and even business data. And once metrics are in Wavefront, you can apply analytics in the form of Wavefront query language. Engineering teams typically use Wavefront to understand performance of their cloud services and distributed applications, as you will see later in Connor's demos. You get instant visibility across all your cloud services, and here's some of the key reasons why cloud native needs metrics analytics. Because of accelerated way of doing business in cloud native world, you need a platform that will scale and not fail over or become sluggish, like we see in popular open source metrics tools, when you all of a sudden add thousands of metrics. You just cannot afford to wait to load your dashboards in your SaaS environment. And you want to be alerted on the behavior of your service as a whole and not be overwhelmed with alerting storms. SaaS needs speed, scale, and intelligence at a very affordable cost, and that is what you get by using Wavefront's metrics-driven analytics. And unlike old-style tools, which can be slow and costly, or newer distributed tracing solutions that provide limited coverage at the expense of increased processing costs, Wavefront platform is cost-efficient and offers massive scale, speed, built-in high availability, advanced query-driven analytics, and customizable dashboards. Our dashboards are exported with one-click URL, driving collaboration and agility. With Wavefront Analytics, you can troubleshoot faster, proactively alert, and detect any leading indicators of anomalies. Instant access and unified visibility drives agility in your code releases, and it enables the same visibility across all teams. And what we typically see is once Wavefront enters an organization, its adoption spreads across hundreds of engineers, enabling typically self-service approach to metrics. And with that, I will turn to Connor for his first demo today.
All right, so we're going to show two demos today. The first of which is not going to be AWS specific. We're just going to give you a bit of a flavor of what Wavefront is all about. And then in the second demo, we'll look at our AWS application. I'm going to use this dashboard to show you a bit of an end-to-end scenario of how an engineer may be paged about an incident and use Wavefront to diagnose and troubleshoot what may be going on. But I'll first of all show a couple of just individual charts to give you a flavor of what Wavefront's all about. This first one is just about the scale and performance of Wavefront. Very simple chart, but I'm actually looking at a year's worth of data here from a cluster of EC2 instances, and it's actually very old data. So it's data from back in 2015, and I'm going to use the query builder here that's built into the product to just take an average of this cluster of machines. Query builder makes it very, very easy to use the Wavefront query language, learn about it, and apply functions on top of your data. I even get a nice little preview here of what's going to happen when I apply this function. And there you go. I just took the average of a cluster of machines over a full year's worth of data, and that query came back in about a second. Another interesting aspect of this is that Wavefront always keeps your data at its original resolution indefinitely. So even though this data is really old, it's not rolled up in any way. And what that allows me to do is look for peaks in this data. Most systems like this will roll up summarized data over time, losing you granularity, which actually comes to things like AWS cost management and capacity planning can be really detrimental. If you've got rolled up average data, you may not get the right answer. If I want to know when did this thing spike up, and I can see that the average was kind of between 1 and 8 or so, let's look at the max instead of the average. And I can see, sure enough, in early April here, there was a very significant peak, much larger than the average, about 10x the size actually. And if I drill into this, I can see it actually lasted for just a little under 10 minutes. So I was able to look at a year's worth of data, see a spike that lasted for 10 minutes, and have that query come back in a second. And if I want to, I can even drop off the average again and see the individual machine that was causing this to happen. That's kind of a quick little example just about the scale and performance of Wavefront. This second one is about the kinds of interesting queries and analytics that you can do with your data. This one is actually a real customer use case. This happened for one of the largest SaaS companies in the world, and it happened to happen within their network. But this same technique can be applied to any kind of data. It doesn't have to be network. It can be anything, application data, infrastructure data, in this case, network. We call this the needle in the haystack problem. And the challenge was the customer knew from their customers that they had a significant network degradation event around the middle of this chart. But they had no idea what had caused it or what was going on. By the time they were looking at it, they were actually out of the woods, but obviously they wanted to understand the root cause so that they could stop it from happening again. One of their network engineers happened upon a kind of a smoking gun, a network switch that behaved very oddly during the time period that the issue was occurring. And they figured, okay, if just this one switch had been bad, our network as a whole would be fine. So there were probably other switches that looked like this. And they originally planned to look at all the switches manually, one by one, to look for similarities. But we were able to show them how Wavefront could just do that for them automatically. So this is Wavefront actually correlating that needle to the haystack of all the switches and pulling out those that are highly correlated. It's kind of like taking the original needle as a magnet, holding it over the haystack and just attracting similar ones to it. Really, really powerful. And what it turned out actually in the customer's environment was that they had a bunch of switches from different vendors. These were all switches from one vendor that all had the same bad firmware that needed to be upgraded. And just very quickly to show you, this same technique can even be used even if you don't know a bad actor or a bad switch to correlate with. Here, I'm just graphing a time box around when we knew that the problem was occurring. And I can correlate the time box to the haystack and get exactly the same results back. Really, really powerful. I know that something odd was happening during this time frame. Now I can find what may have caused it. All right, let's flip back to this dashboard. We've seen a little bit of the power of the Wavefront query language. Here I'm going to drive that capability just off a dashboard. So I don't even need to know anything about the underlying queries or what's going on. I can use this just as an end user. All of the capability that you've seen can be used to drive alerts. And when alerts fire, they can go to PagerDuty, to webhooks, to go into a Slack channel, or in this case, I'm just showing a simple email. And a big problem has happened, and I'm actually getting a link to a dashboard to go and drill in to see what's going on with that problem, get context into it. So looking at the dashboard, I can see, and actually see the alert overlaid here, that our overall transaction rate has fallen off a cliff, and I can see the alert firing. And sure enough, I can see the metric that's causing this alert to fire. As we're collecting this data, and this is the same is true with AWS, as we're collecting data from AWS, we're collecting what account ID it's coming from, what region, what availability zone, et cetera, et cetera. We have all these dimensions around the data. And then it makes it very easy to pivot by those dimensions. So currently I'm looking at the total transaction rate, which is dropping off. I might surmise that this could be a customer problem, but if I look here, I can see that it isn't. All of the customers are kind of dropping off at the same time. So it's not a customer-specific issue, but it could be an app-specific issue. And indeed, in this case, it is. I can see that most of the app servers are continuing to process transactions at the normal rate, but one of them, and it's kind of highlighted on the legend on the left-hand side of my screen here, is at 5, and it's the one that's dropping off. Let's see if we can get even deeper. Although this is already pretty good. If I can determine this quickly, that at 5 is my issue, I'm kind of doing pretty well. But I'm actually going to focus the dashboard on at 5. And what this chart here is showing us now is all of the metrics we're collecting from at 5, from the infrastructure running that application, from the application itself, for instance, the transaction count, which is the thing actually causing the problem in this case. And what I'm going to do is correlate this drop-off in the transaction count with all of those other metrics that we're collecting to see if we can isolate what might have caused this drop-off to occur. And when I do that, I can actually see that right at the same time that the transaction rate was dropping, the free memory was also dropping. And inversely correlated with that, the number of app errors and the rate of garbage collection was spiking up. So I now know within just a few seconds that this is an issue caused by lack of free memory exacerbated by garbage collection getting out of control. This might be enough for me to solve the problem, but if not, it's easy for me to jump into other systems from here to dive in even deeper. Stella mentioned, by the way, about how we can easily link to data. If I want to, I can drill in to this time period. I can easily sync that time period to all the other charts on the dashboard, and I can grab a link to this. I can then share this link with a colleague, put it in an incident report, and anyone can get on the same page as me instantly. And I'll hand back to Stella now.
Thank you, Connor. Thank you, Connor, for this great demo. Connor will show you another demo after I introduce Wavefront Monitoring Suite. And that other demo will talk about AWS, how we gain insight into AWS. So many of our customers typically like to adapt metrics for their own environment, but some of them want instant value. So on top of Wavefront platform, we offer prepackaged monitoring suite. And due to the nature of our platform and the fact that we also run on AWS, one of the most popular one is the Wavefront AWS Monitoring Suite, and that is what we'll cover now. Wavefront AWS Monitoring Suite is a free packaged solution on top of Wavefront platform. With it, you get insight into the performance and utilization of key Amazon Web Services, including Amazon's EC2, ECS, AWS Lambda, and many others. We can pull data using CloudWatch, CloudTrail, and AWS APIs, and you can see instantly what is happening across your AWS footprint. One immediate value that Wavefront AWS Monitoring Suite delivers is that it helps you understand how much money you can save, say, using reserved instances, or you can get insight into spot pricing. In addition, you can overlay events such as code changes and immediately know what is going on with your AWS environment with code pushes. You can combine this with application metrics, and all of a sudden you have instant and unified visibility from top to bottom of the stack. This type of visibility helps developers and DevOps teams, and they can scale fast. In addition to pulling data from AWS, we offer you many different ways to ingest data. You can ingest metrics using collector agents and the Wavefront proxy. A collector agents just Telegraph or cAdvisor, which we use in case of containers, collect metrics such as capacity and usage from your systems and output them to Wavefront proxy. Or you can use code libraries to collect your custom application metrics. You can instrument your code with metrics such as DocWizard or others and send data to Wavefront. And finally, we can also create metrics from logs. If you have popular logging tools, we directly extrapolate metrics from logs as well. And here are some of the key differentiators that DevOps and developer teams get when scaling AWS environment and when use Wavefront. The Wavefront AWS Monitoring Suite, first, as I mentioned, is free, and it gives you instant visibility. You can start looking into your KPIs, such as EC2 performance or your Lambda serverless performance. From these packaged views, our customers typically progress to customize analytics to their own needs. They can take advantage of key AWS functions, such as auto-scaling, and send all metrics to Wavefront to understand any seasonality and know if services are performing as expected. Connor will elaborate on this later on in our box use cases. And since metrics analytics is fast, it helps teams detect and alert on any unpredictable cloud service behaviors and any changes across their entire AWS environment. Thus, making fast and informed business decisions is easy, and your business decisions are synchronized all with developer and DevOps code releases. The Wavefront AWS monitoring suite provides package visibility holistically into key AWS performance, health, and cost metrics, and helps monitoring teams instantly isolate potential resource hotspots. So first, you can start with a summarized view across your entire AWS footprint, as well as you can dive deeper into each individual component view. For example, you can get visibility into your AWS EC2's compute resources performance, health, and cost metrics. From this top view, you can dive even deeper into networking or your EBS metrics, as you can see in Connor's demo shortly. Also, AWS offers various pricing incentives when you reserve your compute resources for a longer term. However, what we learn from our customers, often due to lack of visibility into costing and resource consumption trends, some of engineering teams are really not taking advantage of these savings. Wavefront platform provides out-of-the-box billing and potential saving dashboards that give you visibility into how much savings you can realize. You can access these dashboards within minutes of starting using Wavefront, and it's available even during our free trial. The Wavefront platform also collects spot pricing data, which frequently changes. You can filter spot pricing data metrics per desired dimensions. Your dimensions can be your specific compute instance, or OS, or availability zone. And even our own engineering teams here at Wavefront are taking advantage of spot pricing, and they are saving on costs for our test and QA builds. In addition, many of our customers are using AWS Lambda functions. For instance, developers from German online fashion company called Fashion ID, and they're part of Peak and Kloppenberg, they started to monitor their serverless performance 30 minutes after seeing a Wavefront demo. They could see all their AWS Lambda's performance. And as engineering teams get continuous visibility into their functions, execution, their errors, their invocations, and much more. With this type of insight, you can closely monitor your cloud services, and also you can perform dynamic checks on your function updates. Another example of real-life application of AWS Lambda Analytics is for performing automatic code rollbacks. You can set query-driven alert, and that will trigger to revert to the faulty condition to its previous version. This helps you remediate errors without human intervention. Wavefront alerts can be also fine-tuned to specific alerting condition, which helps you avoid sporadic conditions, and you only get alerts on true faults and anomalies. You can see our wavefront.com blog for free sample codes and on how to perform automatic rollbacks for this example. In addition, the Wavefront AWS Monitoring Suite provides visibility also into Amazon ECS and Docker containers. And for those of you who are using Kubernetes, we also give you visibility into Kubernetes environment outside of AWS. You can see both infrastructure and containerized application performance. With this, DevOps engineers can ensure that there are sufficient resources for containers. While developers, they don't really need to worry about the rate of container changes, spin-ups and spin-downs, because all metrics are preserved at full granularity. And now I will hand over to Connor for our second demo and our first AWS Monitoring Suite demo.
Thank you, Stella. All right, so first thing I'd suggest is for anyone that would like to try any of the stuff you're about to see with your own AWS account, it's really easy to do so. You can sign up for a free trial on wavefront.com. So if you just go to wavefront.com and click Get Started in the top right-hand corner there, you'll get a link to a Wavefront trial account where you can turn on the AWS integration, and see some of these things for your own data. And it only takes a few minutes to do all of this. When you sign up for the trial, it's actually going to walk you through getting started, and it'll point you in the right direction to add your AWS account. If you've already got a Wavefront instance going and you haven't yet turned on the AWS integration, I'll show you how you do that. All you need to do, and this actually goes beyond just AWS, it goes for any of the integrations that we have, including Kubernetes and other things that Stella mentioned. But if I just click integrations in the top menu here, I'll see a bunch of possibilities, one of which is AWS. If I click into it, the setup is very, very simple. So I just click that thing. In this case, I've already got it up and running. But if I didn't, I'd see the button here to set up an Amazon integration. Click that, and it gives me very simple instructions of how to go into the AWS console to set up the required role ARN for us to be able to pull the data for you into Wavefront. So very, very simple. Once you do that, give it 5 minutes or so to start collecting data. And it will also automatically deploy all of those dashboards that Stella was walking you through for you. I'm not going to go through all of them, but I'll highlight some. For instance, here's that summary one. This is going to start populating immediately. Gives you pretty good visibility just into overall what's going on with your AWS accounts. You can see in this particular case, there are 50 running instances currently. They're all on demand, no spot in this case. And we can also see that in this case, they are all running within different availability zones within US West 2. Depending on your environment, you're going to see different things here, of course. Below, we get a little preview of all of the other dashboards and the ability to link out to them. I'm actually going to highlight something here on the ELB dashboard. So let me drill into this one. The ELB dashboard is very helpful for getting good visibility into your entire ELB usage. You get, using the drop-downs above here, pretty good control over exactly how you want to look at this data. By default, it's set to just look at all the ELBs, but you can select various options to drill into more specifically what you want to see. And what I'd like to highlight here is a pattern that you're going to see on a lot of the dashboards that we have. And that is, you see this little tip that says, click the title of the above charts to view a recommended alert query for these things. And if I click in, so I click the title like it says, and I see here that it's showing me alerts that I might want to run over this kind of data. And I think actually if I look at this over a day, there is an interesting period of time where perhaps we're going to see some alerts here. I'm going to turn off this query and turn on the alert condition. I can see when I do that, it's showing me when does this alert condition hold true, and it does at this period of time. Let's just click the Create Alert button here and see how I would actually persist this into Wavefront. I'm highlighting here something pretty cool, and that's the ability to backtest these alerts. Whenever an alert fires in Wavefront, it's going to automatically create events for me for the duration of that alert firing. And of course, send emails, go to PagerDuty, activate webhooks. You can even use that to take automated remediation actions to scale out your environment and things like that. And I can see here when these alerts are going to fire, which is really, really neat. Most systems, you kind of have to set up an alert condition, run it for a while, see if it ever fires or see if it's too noisy and it fires too much. With this, you can actually play with the threshold to get it to a point where you're happy with it. And actually, this looks pretty good. You know, this is catching the issue that I want to catch. Another one of the dashboards that I'll highlight is the billing one. This is looking to help you optimize your usage of reserved instances. And I'm sure a lot of you are doing that already, but I have found it pretty interesting that a lot of our customers that have turned this on are actually not utilizing reserved instances yet. And we often see some really good savings here. For instance, one of our larger customers who traditionally has been on-prem and has started to move towards public cloud recently turned this dashboard on not too long ago. And even though they were just dipping their toes into the water of AWS, this was showing them up to $60,000 a month saving that they could get. What the dashboard is doing is looking at what was the minimum number of instances. You can configure all this, of course, with these variables, but by default, it's what were the minimum number of instances of each type that were running in each availability zone over the past month. And the theory is if you were running at least, and let's see, in this case, we always had at least 4 R4 2x larges, you should probably reserve that many because you always have them. And if I did that, and if I did a 1-year contract with no upfront payment, and I reserved all of these instances, I would save about $3,000 a month. And I can play around with this. I might say, okay, I'm growing all the time, I'm growing my scale. At any given point, wherever my maximum number of instances is the new normal. So I should look for what was the maximum number of instances over the past month instead of the minimum. I can do that. And I can play with different contract settings. Like if I want to commit for 3 years, it jumps up to 8K of savings. So pretty cool to play with. Another really interesting thing that this can help you with, and in this environment it's not showing any, but is detached EBS volumes. So Wavefront can detect for you when you have old detached EBS volumes that are sitting there unused and just costing you money. And again, I'm sure many of you are taking very good care of those volumes, but I have noticed with some customers up to 25% of their monthly spend on EBS was just on detached volumes that they were no longer using. One other cool thing that I'd like to highlight for you around the AWS integration is all of the pricing data that we're pulling in for you. So if I look here, I've got actually all of the EC2 on-demand pricing for every region across the globe. So if you want to, you can trend that over time. And indeed, it's this data that that previous dashboard is using to do its calculations. But we also have all of the spot pricing too. This can be really, really useful to look at in real time and trend it over time what's been going on with spot pricing. I'm just going to look at kind of a random example. Like, let's look at the spot prices for Linux in, let's do US plus 2. And let's say it's a M4 X large. So here's the spot prices live. And if I just stick this chart into looking at the last 8 days, you can see what's been going on. And actually, even this, I'm just kind of a random example, but it's sort of interesting to look at. We can see, when was this? Last Friday, there was a pretty big spike up in spot prices, generally much higher than the norm. It's pretty interesting to see. One other thing I'll just preview here, obviously the focus of this presentation is on AWS, but we are expanding the number of public cloud providers that we have this kind of integration with. And as of recently, we introduced one for Google Cloud as well. So very, very similar to Amazon. You just have a setup tab where it gives you simple instructions for how to get your Google data flowing. And then there were a number of dashboards available to you to give you out-of-the-box visibility into that Google data that we're collecting on your behalf. And with that, I'll hand it back over to Stella.
Thank you very much, Connor. In this part of the presentation, we will showcase 2 customer examples that both of them used Wavefront to scale fast. One of them purely running on AWS, and another having hybrid services. So first, I will go over Space Ape game use case, and then we'll hand over back to Connor to show us how Box scaled to over 800,000 points per second with Wavefront. Space Ape Games is a UK company, and they are behind award-winning games. They were using Wavefront to monitor their key gaming services and their AWS environment in real time. Space Ape Games DevOps engineers are analyzing the performance of their high-level gaming services and all the tiers, all the way down to individual Linux host behavior and utilization metrics. With this view, they can proactively and in real time troubleshoot any issues before their customers experience any critical latencies. They can see exactly what their users are experiencing relative to their cloud service performance. And using our alerting, they can improve their game service user experience and see if there is any percentage of their active users that are having any client errors. Also, SpaceApe Games DevOps team is using DynamoDB to store time-sensitive gaming parameters. The performance of AWS DynamoDB service can directly impact their user experience. They can be concerned with how fast elements of the game are getting loaded. Any delay in DynamoDB performance can result on very bad user experience. So to ensure that they are on top of any service sluggishness, they actually created 2 levels of monitoring DynamoDB performance, and both levels of monitoring are done using Wavefront. They had a custom tool, and they're enriching CloudWatch metrics with more granular changes that are reported in our Wavefront tool by Telegraph agents. And since they are running time-sensitive services, they're pulling both custom code metrics on DynamoDB reads and writes, as well as CloudWatch provided metrics on DynamoDB performance, just to have double layers of safety. SpaceApe Games DevOps engineers are also monitoring the performance of their APIs, gateways, Lambda functions invocations, and even errors from their AWS Lambda functions. By visualizing their URL shortener activity, they're gaining valuable real-time business insight in addition to operational insight. For example, when they initially launched one of their new games, they had lots of traffic from YouTubers. By tracking URL activity, they were able to understand where their customers were coming from. This per-second level insight provide an essential tool for both developers, but also for their marketing and sales teams. SpaceApe Games DevOps engineers are analyzing Amazon Elastic load balancer performance with Wavefront. They can see the impact of increased loads on customer or business experience. And they can chart ELB performance metrics such as ELB request count and ELB request latency, as you can see in their graph. This gives them visibility into how is their gaming service performing. And by monitoring game service request latency, they can see instantly if there are any latencies directly impacting online gamers. DevOps engineers can also do load tests and see if there are any changes that are impacting user experience. They can also see if their application traffic is evenly distributed between availability zones. And this real-time insight is critical for them to understand what's happening when there are many thousands of concurrent active users that are using their service. So they don't have to worry that they will become victims of their own success, and they can grow their services to amazing scale. And since Connor worked with Box from the early days of their growth with Wavefront and them growing their cloud services, he will go over many use cases that Box has.
All right, thanks, Stella. So for anyone not familiar with Box, they're a publicly traded cloud content management company, primarily used by businesses. They actually have over 50 million registered users and over 70,000 paying organizations, many of which rely on Box as their primary source of document and other content storage. So it kind of goes without saying then that their service must be highly available and performant. And to help ensure that, they use Wavefront to gain visibility into their entire environment, from AWS to their on-prem infrastructure, down to their application performance, which, you know, in a lot of ways is the very interesting data. They've been a customer of Wavefront since 2015, and at this point they have over 400 engineers using Wavefront across development, operations, and they're even business users as well. They use Wavefront at very high scale. So in fact, since this slide was produced, I think that their steady state rate is even a little higher than 500,000 metrics per second. And so they're sending huge quantities of data into the system, and they use it every day to understand the impact of changes that they're making in their environment. And I'd like to share some examples of how boxes use Wavefront in their growing use of the public cloud. The first use case just describes, and it's kind of simple, the very first service that Box moved to AWS. There was a healthy amount of skepticism within the company around whether moving to AWS, to public cloud, would be a good idea or not. And the SRE leads at Box were actually able to use Wavefront to prove that it would work, like using metrics, using real evidence to show that moving to the public cloud would not only work, but could actually save Box money. If I remember correctly, what happened here was they started offering, this is showing, the chart is showing data from back then, they started offering this particular service first to the freemium users of Box on the public cloud, and then when they proved out its success, they started migrating all of Box of this particular service to public cloud. What the top chart is showing here is the blue band is fairly narrow at that point in time. That's the number of EC2 instances running this service compared to the on-prem stuff. What's pretty interesting is that on the lower chart, we can see that the number of jobs running per EC2 host is much higher. That's the orange line there. It's much higher than in the data centers. And so they're actually utilizing the EC2 instances much more effectively than they were the data center hosts. And by doing this, they're able to actually prove and show that they could get a 70% cost savings using AWS versus the private cloud. And this helped pave a way for them to move fast and scale out their adoption of public cloud at Box. And at this point, they're actually now looking at multiple clouds from different providers. This next one is a pretty neat example around a Box project called Zones. And the idea behind this project was to allow a customer to be able to select and run a data center or use Box in a data center close to them by running on public cloud regions. So say you're a German customer and you have data locality requirements, security requirements around where your data can be stored, you can choose to have that data stay in the German region. The graph here shows download latency. Lower is better. The blue line represents what was the standard Box service without this Zones feature. The green line represents the first internal version of this feature, which you can see actually made things slightly worse. And the purple line represents the V2 of Zones, the first publicly available one, which was significantly better than the original Box standard. One of the really cool and kind of interesting things about this particular example is that the engineer that built this dashboard came across this screenshot in a presentation that a product manager had given to senior level executives at Box about the progress of this Zones project. And it's kind of a testament both to how easy it is to find data in Wavefront, that product manager was able to go and find this chart themselves and make use of it. But it also shows the power of metrics to grow you as an engineer's influence in an organization. The person that built this chart was able to influence and show progress of changes that were being made when they weren't even in the room. They built out this data and other people started sort of virally using it. Pretty cool. This graph represents another service that Box moved to the public cloud. Basically two clusters that combined together run this service. It's pretty simple, and it just shows the number of EC2 instances on the y-axis over a month worth of time. And you can see right away that it varies quite a bit. There's auto-scaling going on here, and the service is responding to that demand at any given time by adding nodes during peak times or removing nodes to save costs during the lulls. What can we deduce from a chart like this? Well, quite a bit. You can see that there's a trend for the load to be less on a weekend and higher on weekdays. And we can therefore predict the low water mark and the high water mark and create alerts around those. So you can create those alerts really simply using just thresholds. As you could say, you can see that it should never be below 30. So you could just have a simple alert that says, if the number of instances ever goes below 30, we know that something bad is going on. Or if you want, Wavefront can actually do some more complex things for you. It can calculate for you automatically what's the normal number of instances at any given time. So what's normal for 12 p.m. on a Monday is very different from what's normal from 12 p.m. on a Saturday. And it can calculate this given the historical trends of that data and alert you if you ever deviate significantly from that. And finally, and I kind of showed this in the demo, Box engineers are taking advantage of AWS spot pricing. Their infrastructure team is using up-to-the-second, fine-grained visibility of what's going on with spot pricing to help them keep costs down. They're using spot for build jobs where they can tolerate some churn in the number of instances. Now, and back to Stella.
Thank you, Connor. So to recap, the Wavefront AWS Monitoring Suite gives you performance, pricing, and business insight into cloud application, cloud performance of all your metrics in one location. We help you confidently scale your cloud application without any blind spots. And with this, I'll conclude our presentation part of our webinar, and we'll start taking questions. If you have questions, please type them in the questions window. We will try to address all the questions, and if we don't get to your questions, we'll respond after the webinar. So let me go to our first question. Why cannot I just use CloudWatch metrics directly without Wavefront? Connor, maybe you can address this one.
Yeah, sure. I think there's kind of, I guess, two reasons for that. One is the ability for Wavefront to combine all of your metrics together. So if you're just using CloudWatch, okay, you've got your CloudWatch data there. But with Wavefront, you can have your CloudWatch data combined with your custom application metrics, combined with your other, if you do have some on-prem stuff as well, combined with that infrastructure metrics, all together to correlate across everything. So that's one reason. Getting visibility beyond just CloudWatch. And the other is simply, and I hope you saw some of this in the demos, CloudWatch doesn't give you the same level of flexibility to slice and dice and manipulate and do analytics on your data the way Wavefront does. So I think, Stella, actually, you covered this use case of Fashion ID using Wavefront to monitor Lambda. They were just monitoring CloudWatch data only, but Wavefront allowed them to do that much better than CloudWatch alone did.
Thanks, Connor. We have another question. The question is, do I get charged for Wavefront AWS Suite? As I mentioned, the whole AWS Suite is free, so you can give a try to our free trial, and you can actually try even directly looking into your performance metrics, your cost metrics. And the second question around pricing is, can you explain the Wavefront pricing model? Connor, if you can take a look at this one.
Okay. Wavefront pricing, it's pretty straightforward, pretty simple model. We just charge you for what you send. So we talked about how Box is sending a large number of measurements per second into Wavefront. That's essentially how Wavefront pricing works, just how much data are you sending to us every second. We don't charge for users, we don't charge for the AWS application, just pure data rate, which is pretty simple. And it's nice because it lets you control your costs in a very fine-grained way. Like if you want to reduce your cost, just reduce the frequency at which you're emitting data. So pretty straightforward. And actually, kind of going back to the previous question about why not just CloudWatch. CloudWatch data doesn't tend to report that frequently anyway. So the costs for using the AWS integration are quite minimal, actually.
Thanks, Connor. Another question from our chat window is, how long do you retain data for? So the data is, we don't really have any limits on retaining data. Data is retained in full granularity. Metrics are compressed at a high compression rate, so we really don't worry about storage or processing costs. We have customers that are storing 4 years worth of data at their full granularity. So the only limitation is your contract with Wavefront. Another question is, how long do you retain data? Sorry, another question is, what about other environments? I have Kubernetes. Yes, I mentioned Kubernetes we provide visibility across the whole top level view all the way down to container level individual containers, and you can even tag containers so you can see as they move around. You can follow if there are any issues from host to host. Connor, any other questions?
Let's see, yeah. There was a question about whether the out-of-the-box dashboards can be customized. Yes, they can. The specific out-of-the-box one we mark as read-only, so that as we make improvements to them, we can ship those improvements without clobbering your changes. But it's super easy to just clone one of the out-of-the-box dashboards and just start building your own. And it's also really trivial to make your own dashboards from scratch. So not even using the out-of-the-box ones at all, but just starting from scratch to build something completely custom for yourself. Very, very easy to do. Another question here is, what's the frequency of data pull from AWS? That's something that you can control. So when you set up the integration, it's going to pick a 5-minute interval by default and pull all CloudWatch metrics every 5 minutes. But if you wish, you can change that. And actually, you can even do it on a per metric basis. So there are some metrics in CloudWatch that either by default report every 1 minute, or you can pay a little extra to have them at 1 minute granularity. And you can configure the system to pull those metrics every minute, pull these other metrics every 5 minutes, and maybe even for ones that you don't care about that much, you could set it up to say, just pull these every 30 minutes or every 60 minutes. It's totally up to you. Let's see here. There's a question here. Do you provide a reference architecture to implement Wavefront monitoring in various environments?
It's not on. We are not really an on-premises solution, so we are hosted in the cloud. So you really don't worry about reference architectures, if that's your question. I think this is our last question for today. And thank you very much for attending our webinar. Chris?
Great. Well, I'd just like to thank Stella and Connor for today's presentation. Also want to be sure to thank today's sponsor, Wavefront by VMware, for providing the DZone audience with a great presentation. Lastly, we'd just like to thank everybody that joined us today. We really hope that you learned something new that will help you in your developer career. Everybody have a great day, and we'll see you next time.
Thanks, everybody.
Thank you.